Can you believe it's June already? Feels like this year is moving so fast. And with the start of June comes the start of hurricane season. Admittedly, I feel mixed about the approaching hurricane season. On one hand, I'm excited for all the interesting weather it's going to bring, both from hurricanes along with the general storminess of the summertime months. But I also know that this year will likely go down in the history books as one of the worst, as I'm sure you've heard. I'm sure you've heard enough of that already. Pretty much every major source of meteorological information, along with media companies and internet personalities, are predicting an above average hurricane season. The National Hurricane Center, the Weather Channel, Colorado State University, news outlets such as NBC, ABC, Fox, CNN, you name it. However, it is pretty clear to see why there is such a clear consensus on this hurricane season being extremely active or even potentially historic. There are two primary driving factors behind the predictions for an active hurricane season in 2024. One, the Atlantic Ocean is incredibly warm and will only get even hotter as we reach the summertime months. As of writing the script at the beginning of June, sea surface temperatures across much of the Atlantic range from 82 to 86 degrees Fahrenheit already. These kinds of water temperatures would be more appropriate for July or early August, not June. Warmer sea surface temperatures in the Atlantic means a higher potential for the formation of tropical cyclones and the sustainability of them. On top of that, science have shown in recent years that higher sea surface temperatures also contribute to the increased odds of hurricanes rapidly intensifying. I have a video on this topic if you would like to know more, so I'll keep the explanation in this one brief. Rapid intensification is a term used for tropical storms or hurricanes that strengthen quickly. They have to increase by a sustained maximum wind speed of at least 35 miles per hour within a 24-hour period. Some storms in recent years, such as last year's Otis, have had a bit of a habit of exploding right before they hit land, too. The second main factor that is contributing to all of these active forecasts for this year's hurricane season is the development of a La Nina weather pattern. A La Nina occurs due to cooler than average subsurface water temperatures emerging in the Pacific Ocean. Over time, easterly trade winds develop, pushing warm water away towards Asia. This has a variety of effects on the U.S. climate, such as leading to a generally drier winter in the south with a wetter winter up north. However, the more dramatic long-term effect of La Nina can also be more subtle to us at home at first. La Nina weather patterns lead to drastically reduced upper-level winds over the Atlantic Ocean and the Caribbean. These strong upper-level winds can prevent what would be hurricanes from even developing or shear apart existing storms. With less overall wind shear in the Atlantic and Caribbean this season, whatever storms form should have a much better chance of developing and sustaining themselves. With those two factors in play, it seems pretty likely we will have an above-average hurricane season. So, for today, with it being pretty early in the hurricane season, I want to take this opportunity to look at tropical storms. Well, what is a tropical storm? Tropical cyclones are broken up into three different categories, all depending on their wind speed. The weakest form of a tropical cyclone, a depression, has wind speeds between 30 to 39 miles per hour. From 39 to 73 miles per hour, a tropical cyclone is called a tropical storm. From 74 miles per hour and above, a tropical cyclone is called a hurricane, at least in America. Tropical storms are often overlooked in the discussion on many hurricane seasons due to their perceived lack of strength. These storms are often much less organized than hurricanes, and generally do bring less damage with them than the typical major hurricane, for example. Tropical storms do occur throughout the entire hurricane season, but happen most commonly early and late in the season. And by that, I mean it's more common for storms to become tropical storms, but not have enough strength to reach hurricane status. However, I think it's important to look at all storms, even the ones that aren't as severe as some of the big-name hurricanes. Because despite the notion that tropical storms are less severe, there have been numerous times in history where tropical storms have brought more destruction than even some major hurricanes bring. Today, I want to shine some light on the underdogs of the tropical cyclone world, and in order to do that, I've selected a few tropical storms from history that were both devastating and also piqued my interest. This is in no way a complete or ordered list, just a few that I wanted to share with y'all today. Storm number 1, Tropical Storm Beryl. And why the storm was notable? Well, it was the strongest off-season landfalling tropical cyclone. Tropical Storm Beryl formed late on the night of May 25, 2012, despite the precursor low-pressure system existing as early as May 16th. This precursor system brought heavy rain to Florida before Beryl's eventual landfall, including nearly 10 inches of rainfall in one day at the Miami International Airport. By the time Beryl became a tropical storm, the National Hurricane Center was already anticipating a U.S. landfall. The first graphic issued for Beryl depicts the storm position far off the southeastern coast, with its sights aimed at the first coast of Florida. Tropical cyclone landfalls are pretty rare in this part of the state, so that's another thing that makes this system notable. Beryl continued to meander towards the Florida coastline, reaching a peak intensity of 70 miles per hour on the evening of May 27th. Shortly after midnight on May 28th, Beryl made landfall in Jacksonville Beach, Florida, with peak wind speeds of 65 miles per hour. This makes Beryl the strongest preseason landfalling tropical cyclone in U.S. history. The storm would bring strong winds and heavy rainfall far inland, along with a few inches of storm surge along the east coast of Florida. By 11 a.m., the storm was approaching the Florida-Georgia line and had weakened to a tropical depression. Before moving into Georgia, Beryl left behind quite the mess in Florida. This included two EF0 tornadoes, one near Port St. Lucie and the other being along the Big Bend region. 38,000 residents in Jacksonville alone lost power, and many locations across the state experienced flooding from heavy rainfall. The city of Wellborn received a whopping 15 inches of rain from Beryl. Beryl continued causing chaos throughout the southeast between May 28th and May 30th, primarily impacting Georgia, along with North and South Carolina. Beryl was able to re-intensify back to a tropical storm on May 30th as it was trekking across South Carolina as well. The most notable event to occur from Beryl during its time outside of Florida was near the town of Paleto, North Carolina. Here, a strong EF1 tornado with peak wind speeds of 110 miles per hour damaged 67 homes and destroyed 3 mobile homes along with a garage. In Beryl's wake, 3 people were unfortunately killed, 1 directly and 2 indirectly. In addition to that, Beryl caused over $142,000 in property damage across the southeast. For our second storm, we're going to look at Tropical Storm Fay from 2008. And why the storm was notable? Well, it had quite the strange path, but more importantly, it caused a major tornado outbreak across the south. Tropical cyclones producing tornadoes is nothing new. In fact, they do it pretty often. However, when it comes to producing strong and especially many tornadoes, that is typically something reserved for the hurricanes. But throughout much of mid to late August of 2008, Tropical Storm Fay brought 50 tornadoes to the southeast. Let's step back a little bit and take a look at the origins of Tropical Storm Fay. The system started out as a tropical wave off the coast of Africa all the way back on August 7, 2008. However, it would take until August 15th for the storm to develop into a tropical storm. This first advisory was issued at 5 p.m. on the 15th, when the newly named Fay was designated off the southeast coast of the island of Hispaniola. Fay would bring heavy rainfall and winds between 40 to 50 miles per hour to much of the Caribbean islands as it approached the southeastern United States. Over the 3 days it took to reach Florida, Fay was forecasted to become a hurricane at multiple points before making a U.S. landfall. However, this would not come to fruition. Fay would make landfall in Florida numerous times. Can you guess how many? Not once, not twice, not even 3 times, but 4 different times. The first landfall occurred around 5 p.m. in the Florida Keys on August 18, 2008. And at about 5 a.m. the next morning, the storm would make its second landfall at Cape Romano with sustained winds of 65 miles per hour. Fay then moved inland, intensifying further than it ever had over the open ocean to have sustained winds of 70 miles per hour. An eye-like feature can even be noticed on satellite imagery once it almost reached hurricane strength. As Fay approached the east coast of Florida on the morning of August 20th, it was forecast to move back out over warm Atlantic waters again and was forecast yet again to become a hurricane. However, this did not end up happening. Fay ended up stalling for almost an entire day off the coast of Daytona Beach, which allowed it to regain some of the strength it lost over the Florida peninsula. After waiting out the clock for nearly a day over the Atlantic Ocean, Fay finally managed to meander its way back inland, making its third landfall near Flagler Beach, Florida, on the afternoon of August 21st. The storm would drift westward throughout the rest of the evening and through the day on August 22nd. Fay would once again leave Florida through the Big Bend region before making its fourth and final U.S. landfall near Apalachicola on the morning of August 23rd. The storm would finally leave Florida late that evening as a tropical depression, moving into Alabama and the rest of the deep south over the next few days as an extratropical low. Remember how I mentioned the storm spawned 50 tornadoes? More than half of those spawned in Florida and Alabama, with 15 spawning in Florida and 13 spawning in Alabama. Over 90% of the tornadoes that were spawned from Fay were on the weaker end of things, either being an EF0 or an EF1. However, that does not mean that they were not damaging. For example, an EF1 tornado hit the towns of Oakwood and Gainesville to the northeast of the Atlanta metro area. This tornado was on the ground for less than 5 miles but caused $750,000 in damages. 3 EF2 tornadoes would occur as a result of Tropical Storm Fay. The first EF2 occurred early on in Fay's tornado outbreak, happening on August 19th as the storm was moving over central Florida. The tornado had a peak wind speed of around 115 miles per hour and caused over $1 million in damages in the Wellington area, a suburb of Palm Beach. More concerningly than that, the other 2 EF2 tornadoes were pretty late into Fay's run. The first of the 2 spawned in Claiborne County, Alabama on the afternoon of August 25th. I said it was concerning a moment ago because by this point Fay had already worked well inland and had weakened significantly. However, that did not stop the storm from producing tornadoes. The first tornado, despite being pretty strong, thankfully was only on the ground for less than half a mile. The last EF2 from Tropical Storm Fay happened in Anderson and Pickens counties of South Carolina on August 26th. Numerous tornadoes actually formed in this area on that day, despite the center circulation of Fay being over 300 miles away. Fay would produce a few more weak EF0 tornadoes in North and South Carolina on August 26th and 27th before finally coming to an end. Fay was an extremely wide-reaching, damaging, and strange storm. From its erratic path to its unexpected tornado outbreak, Fay had quite a lot to offer. The storm would cause over $560 million in damages, or about $815 million in today's money. Fay would also take the lives of 36 people across the US, Haiti, Jamaica, and the Dominican Republic. All of this happened without Fay ever reaching hurricane strength. For our last storm, we have to go all the way back to 2001 to look at Tropical Storm Allison, the first storm of that year's hurricane season. And why was it notable? It brought devastating flooding to Texas and really a good chunk of the southeast. It was a very long-lasting storm, as you will see in just a moment. On the morning of June 5th, 2001, residents in coastal southeastern Texas were greeted with quite a surprise. Overnight, a tropical storm had developed to the south of Galveston, and it was forecast to move inland later that day. The system did not come out of nowhere. In fact, the tropical wave that developed into Tropical Storm Allison had been tracked since May 21st, when it came off the coast of Africa. Remaining rather benign for most of its existence up until June 4th, the storm was not expected to be anything major. However, that notion could not be further from the truth. Starting on June 4th, the wave began to develop strong thunderstorms on the eastern side of its circulation. The National Hurricane Center was keeping a close watch on this wave and felt that a tropical depression could form soon. By 8 a.m. on the morning of June 5th, the storm developed a broad, low-level circulation. The National Hurricane Center made the call to give the storm the name of Allison, and the first official tropical cyclone of the 2001 hurricane season was officially underway. The storm would quickly strengthen, developing heavy rain bands and sustained wind speeds of 60 miles per hour, though the storm was not anticipated to intensify much further due to its proximity to the land and cool offshore ocean temperatures. At around 4 p.m. local time, Tropical Storm Allison made landfall near Freeport, Texas, with sustained wind speeds of 50 miles per hour. The storm would weaken quickly, slowly dragging its way throughout East Texas during the evening and overnight hours. As mentioned, Allison weakened quickly upon moving inland, leading the National Hurricane Center to stop issuing advisories on the storm. However, that did not mean that the storm was over. Far from it. From June 6th through the 9th, the weakened Allison would continue to drift slowly around Texas, even performing a full loop in its path. This entire time, it is dumping absolutely catastrophic amounts of rain on the flatlands of eastern Texas. So let's take a look at some of those totals. Much of the worst flooding in Texas associated with Tropical Storm Allison occurred in and around the Houston and Galveston metropolitan areas. Starting on June 5th, the day of landfall, a combination of heavy rain from outer rain bands along with storm surge brought heavy flooding to Galveston and much of the southeast coast of Texas. As Allison moved inland, throughout the 6th and the 7th, extremely heavy rainfall occurred around the storm's core, bringing up to a foot of rain in cities like Freeport. Again, on the 8th and the 9th, heavy rainfall events would dump catastrophic amounts of rain on Houston and the rest of Harris County. In just 12 hours, some areas saw upwards of 28 inches of rainfall. That's over 2 feet. By the end of the storm's reign, no pun intended, southeast Texas was in shambles. Across much of this region, rainfall totals topped out from anywhere between 1 to 3 feet of rain in just 5 days. This led to so much damage that there's an entire Wikipedia article dedicated to the damage Allison did in just Texas. And just in Harris County alone, the county that contains the city of Houston, 95,000 vehicles and 73,000 homes were flooded. Across the state of Texas, 2,744 homes were considered completely destroyed. Residential damages alone ended up costing $1.76 billion. Another estimated $2 billion occurred at the Texas Medical Center, which is the biggest medical complex in the world. And I mean, it's really big. This one complex alone employs over 106,000 people. Despite all of the insane damage caused by Tropical Storm Allison and its deluge of heavy rainfall over Texas, it's still not the most catastrophic tropical storm when it comes to flooding. Not even the worst one to hit Texas, actually. That honor goes to Tropical Storm Amelia of 1978, which formed and played out in a very similar way to Allison. However, the difference with Tropical Storm Allison is that it had its sights set on more than just one U.S. state. By June 10th, the weakened remnants of Allison finally made their way out of Texas and back out over the Gulf of Mexico. Despite fairly favorable conditions, Allison did not redevelop into a tropical storm. Instead, the system developed into a subtropical depression. This means that Allison shifted from a warm core storm to a cold core storm. And to put it more simply, rather than the cyclone being fueled by warm ocean waters, it was now being fueled by the collision of warm and cold air. Essentially, Allison was acting more like a traditional storm system you'd see throughout the year over the continental US, rather than a traditional tropical storm. Despite the subtropical label, that does not mean that the storm weakened by very much. In fact, Allison actually managed to intensify further after its next landfall in southeastern Louisiana early on the morning of June 11th. Wind speeds would once again peak at 45 miles per hour, and an eye-like feature was able to be seen on radar. And the story of subtropical storm Allison in Louisiana was a bit of a 1-2 punch. Rain bands did extend well to the east when Allison made landfall as a tropical storm back on June 5th. As the storm moved up and through East Texas, it also brought rain and even an F1 tornado to Louisiana. The second round of rain and flooding that came with the landfall of subtropical storm Allison, however, was really just the icing on the soggy cake. When all was said and done in Louisiana, many areas saw upwards of 1 to 2 feet of rain. The highest rainfall total occurred in the town of Thibodaux, topping out at 29.86 inches. Allison would weaken into a subtropical depression as it continued to move further into the deep south in the early hours of June 12, 2001. But as we've seen multiple times, traditional measures of strength are relative when it comes to a storm like Allison. Heavy rainfall continued to be a major part of the story, with areas of Mississippi, Georgia, and Florida all seeing upwards of 10 inches of rain in one day. But aside from heavy rainfall, there was also severe weather. A cluster of severe thunderstorms that formed on the outer remnants of Allison destroyed 10 homes, injuring 5 people in the early morning hours of June 12th. Wind gusts from the storm system were estimated to be in excess of 95 miles per hour. Allison also managed to spawn 26 tornadoes, according to NOAA's Tropical Tornado Research page. Notably, most of these occurred long after the initial landfall of Allison and more towards the second landfall on June 11th. When organizing this list of tornadoes by date, we could see that the rate of occurrence really picks up between June 11th and the 13th. Many of these tornadoes spawned in South Carolina on June 13th, which was the most for one state in the storm's duration. Thankfully, many of the tornadoes to occur with Allison were pretty minor, with none reaching beyond EF1 status. Allison continued to slowly work its way through the southeast and eventually the eastern seaboard and northeast throughout June 13th to the 17th. And I do mean slowly. Allison seemed to nearly stall over North Carolina, with the storm taking almost 2 full days to clear the state. Along much of this inland path, the story remained the same. Allison would continue to drop heavy rainfall, along with bringing strong winds and the occasional tornado in relation to isolated thunderstorms within its field of influence. Finally, the storm would leave the United States for the last time on June 16th off the southeastern coast of Virginia. As one last act of spite, almost like a taunt, Allison intensified once more to a subtropical storm as it moved to the south of Long Island, New York. Thankfully, though, by this point, Allison was already over water and would soon become extratropical as it rocketed off into the Atlantic Ocean. One of the truly impressive features of Tropical Storm Allison is just how long it lasted and how much strength it was able to maintain at numerous points in its life. Typically, when tropical cyclones make landfall, they weaken rapidly and break apart within a few days. Their remnants may remain, but usually they do not produce many impressive effects once the system reaches this point. But we saw numerous examples of Allison producing monster winds, tornadoes, and rainfall even days after landfall. So why is that? While there isn't one definitive answer for that question, one potential factor could be the warm and unstable atmosphere along the Gulf Coast. There's a phenomenon in tropical cyclone meteorology known as the brown ocean effect. This occurs when a tropical cyclone moves over land and is fueled by extremely moist and hot conditions on the ground. This is due in large part to the latent heat that is released by damp ground soil in combination with heating from the sun. In some parts of the country, the atmosphere can mimic the hot, humid conditions of areas such as the Gulf of Mexico, such as Texas, Mississippi, or Florida even. A study from NASA in 2013 noted that out of 227 tropical storms they researched, 45 of them maintained or even gained strength upon landfall, or about 20%. This was initially thought to be solely due to tropical cyclones transitioning to subtropical cyclones. However, it was found that some of the storms in this study did not transform into cold core storms, meaning they stayed tropical in nature despite being over land. Tropical Storm Allison went down in the history books as one of the most devastating tropical storms to hit not just Texas, but the United States as a whole. An early season storm, one that formed and made landfall rather quickly, but would not leave the country alone for nearly 2 full weeks in that wet summer of 2001. 5 states would be declared disaster zones in the wake of the storm, with Allison leaving behind $9 billion in 2001 money, or around $15.5 billion in 2024 money. Allison also took the lives of 55 Americans and injured hundreds more. Due to the extreme damage and loss of life caused by Tropical Storm Allison, the name was retired from use in the Atlantic Basin in 2002. And with those 3 examples, I hope I have convinced you that tropical storms can be a force to be reckoned with. Remember, during hurricane season, you have to take every storm seriously, no matter how weak it might look. With that, thank y'all for watching. I hope you enjoyed this video as much as I enjoyed putting it together. This is the most work I think I've put into one of these kinds of videos so far on this channel, and I hope that reflects in the viewing experience for y'all. We'll be back very soon with more documentary-style videos, along with some storm chasing as we get deeper into the summertime months. Thank you again for watching, and I hope you guys have a great summer.